Today we're going to take a look at molecules and polymers. Now, have you ever tried to pop a balloon with a needle or a pointy object such as this wooden skewer? What happens when we put a pointy item or object like this into the side of a balloon? I'm not going to try it quite yet. I'm going to teach you today a way to put a pointy object such as a skewer through a balloon without popping it. Can it be done? What do I need for this experiment, you might ask? A balloon blown up and tied at the base, a metal or wooden skewer such as the one you see here, a piece of tape, a few little pins like the ones you see in this jar, and something called petroleum jelly. Also Vaseline, if you have it in your house, that works too. A few little objects from laying around the house and an amazing experiment yet to come. Okay, let's give it a try. We'll take our skewer here. In this case we're using a wooden skewer, which I have not tried before, so this will be a nice experiment for all of us. And I'll take a little of this petroleum jelly and rub it alongside the skewer, just like so. Then I'm going to take my balloon, red balloon for us. You can choose whatever color. That, of course, is not going to affect the experiment. And with bravery, you will take the skewer and hopefully, come on. It worked! We put it through the end of the balloon, and now let's try to put it through the top and see if it stays intact or if it pops. What do you think will happen? And there it went! A skewered balloon with a pointed object such as this wooden skewer right through it, and yet it stayed intact. But how does that happen? Rubber is made up of long molecules called polymers. When these polymers are linked together, this is called cross-linking. These links hold the polymer molecules together and allow the rubber to stretch only up to a point. When the stress or tension placed on the cross-links is too great, the polymer will break, as it happens when you see a balloon pop. When the force on the polymer molecules is too great, they will stretch and fall apart, and the polymer will break. When you look at a balloon, you'll notice some parts of the rubber seem darker than the other when it's inflated. The ends are darker because the surface area is not stretched or doesn't have as much tension as you see on the sides of the balloon here, where it's a lighter color. Our next question is if we can stick a pin in the side of the balloon and whether or not it will pop. Now, because the tension is too great on the edges right now, probably it will, but what can we do to reinforce the surface of this balloon? Aha! We could use tape. Let's give it a try. Here's our tape here. We place it along the side of the balloon to reinforce the polymers that are the cross-links and polymers that are being stretched out. And now I'll take my pin, I'll dip it into the petroleum, and now, with bravery once again, we will take our pin and insert it to the side of the balloon, hoping that our reinforcement will keep the polymers and cross-linking together. Let's try. We did it! We placed a pin through the side of a balloon without it popping because of the reinforcement that we created by the tape. Wonderful! Can we be brave and try it again? Let's give it a go. And there it is! How many times can we add pins to the side of the balloon with the reinforced tape and still keep it going? And now, let's try to put the pin into the side where there is not the reinforcement of the tape. And what happens? What was supposed to happen? It still worked. Well, the tension must not have been strong enough on the side of the balloon pulling the rubber apart to cause this to break apart the crosslinks. So we would have had to inflate the balloon to a greater degree to make the tension stronger. Try that again and look, it begins to deflate as the pin fell out. Okay, that didn't work quite as planned, but it was still a good learning lesson that the amount of stretch on the side of the balloon is really important to consider. This might be what happens when we don't reinforce the polymers. Join us next time for some more at-home experiments.